Question 4 part 1 gives you two information. First being equation of the curve, and second information being that a minimum point. So for example, it's a point M will be the minimum point. In turn, it asks you if this very point M itself satisfy this very. At first, students are very stuck as to what this question asking in the first place, but if you look closely, it only gives you x actually. It doesn't give you any. Therefore, it's actually just asking for your x coordinate. That x coordinate of M is cube root of 3. But of course, it's not easy to see this. So the only thing you can do when you see this question is that you see minimum point. Therefore, you just differentiate this equation first. After all, that's the only thing you can do to get minimum point. But since this is difficult to differentiate directly, we express in this form first and differentiate. So once again, the power negative half, you push it to the front. So 6 times negative half and you get minus 3. Whereas for this power itself, is you just minus 1. Then here it's relatively straightforward. I don't want to explain too much on this. From here, negative power, once you push it to the denominator, it becomes a positive. And to get from this step to this step, simply this principle. With this, we got our gradient. So it's the general equation of gradient here at any point. But it's still not specific yet. It's still not exactly at point M. So how do you get point M? We know that gradient here is actually 0 because it's a minimum point. So we use this information and make dy dx. So just push it down actually. Again, simplify. Now here's the way it gets a bit, if you're not used to it. So you get 3 over 2 is equal to 3. And the next step this. As to how we get this, right? The first step is we square both sides. So after squaring, it cancels out. Then next, cube root both ends. So after cube rooting this, it cancels out. So what I left with is just 3 to the power of 2 over 3. Actually, you don't need to go so far. You just need to square it actually. Sorry, so in essence, you square both ends. And that's how you get to this stage. And that's your answer for part 2. Sorry, for part 1.